In this video, we'll discuss GitHub and social coding platforms. GitHub is a place to store and host Git repositories. For clarity, let me highlight that Git and GitHub are not the same. However, these two applications have a symbiotic relationship. In short, Git repositories can be hosted remotely at GitHub. There are other similar hosts such as GitLab and Bitbucket, and all three sites serve as hosts for Git remote repositories. In addition to these public hosts, Duke University runs its own instances of GitLab, for example, gitlab.oit.duke.edu. You can log into Duke's instance of GitLab using your NetID. Before I explain more about GitHub, let me reprise an abridged definition of Git. Git is a version control system that tracks file changes and enables file distribution. People use Git for tracking files that comprise the lifecycle of computational projects. When we apply Git version control to a folder on our local file system, we can also use Git to push local Git repos up to a remote. In this case, we will use GitHub to host our remote. Using GitHub in this way enables file distribution as well as collaboration. GitHub also provides several project management features related to computational workflows. For example, access control, task distribution, bug tracking, wiki documentation, and Kanban planning. For now, we'll simply discuss the remote hosting features of file distribution and collaboration. How does this work? When I push a remote copy of my Git repo to GitHub, I'm making my remote publicly available. In this way, I can profile and distribute my work as well as share the project timeline. Alternatively, I could maintain my GitHub remote as a private repo, but we'll talk about public access. People with access permissions can clone a copy of my work. Since my GitHub repo is public, anyone can clone my repository. Cloning is basically downloading the repo hosted at GitHub. For now, let's assume our closest collaborators are granted open permission and will clone the repo. The difference between forking and cloning often comes down to authoring permissions. In some cases, a person will fork a GitHub repository rather than clone. In this way, less trusted or as of yet unknown collaborators can fork a repo. After forking, a collaborator can suggest changes through a process known as a pull request or a PR. For example, someone might find a mistake in my work and then contribute corrections in the form of a pull request. When PRs are submitted, the GitHub repo editor has the opportunity to accept or reject the pull request. All accepted PR changes become part of this repository's commit history. This process automatically extends my repo version control timeline. In summary, Git and GitHub are two separate tools which, when adopted, deliver several reproducibility benefits. Git is the engine for tracking changes to your repository project. GitHub is a web host used for distributing repositories. These two tools afford a robust collaboration environment.